Hello and welcome. My name is Chris Henley, and today we're going to talk about a new concept called HierarchyID in SQL Server 2008. As part of the drive to move SQL Server 2008 beyond relational, a new hierarchy ID data type has been added. The hierarchy ID type logically stores information about a single node in a hierarchy tree by encoding the path from the root of the tree to the node. Now, examples of how this may be used include an organizational structure, a file system, a set of tasks in a project, or a taxonomy of language terms. Now, in this demonstration, we'll actually look at how to create an organizational structure for a business, and we'll actually look at how we would do it the traditional method, and we'll compare that to the way that we might do this using hierarchy ID. Now, for both of these examples, we're going to consider the same case with a standard corporate organization structure using a series of departments. Let's start by building our corporate org structure the old way. First, we'll create the schema for the department hierarchy, then we'll add an index on the parent ID column, and next we create the top level department with a parent ID of null. Now, since it's the root node in the tree, we're going to go ahead and use the null value. Finally, we're going to insert all of our additional departments. And here's what our org table will actually look like. Now, as you can see, to create the hierarchy, we use the parent ID column to reference the parent node in the department ID column. And notice that creating this new department in the org table is really quite trivial. All we have to do is assign a parent ID to the department, and voila, it's done. Now that we've populated the org chart, one of the most common things we might want to do with it is display the structure of all or part of the tree. Now, this is actually a pretty complicated operation to perform on a standard org chart, and it requires some pretty complex code to traverse and then explode the tree. More importantly, since the entire hierarchy needs to be calculated and then exploded each time this stored procedure is run, this is actually a pretty resource-intensive procedure to perform on this server. Let's go ahead and look at how we can create the same org tree using the new hierarchy ID data type. Now, the same table org new is used to structure the departments of a corporation. It includes a unique identifier for the department name, a hierarchy ID column that's going to store the position of the department in the corporate structure. The table also contains a computed column for the level of the node. Now, this is so we can create a breadth first index for the hierarchy. This is more efficient for returning hierarchy ID values on the same level, such as the direct descendants for a department or maybe all the top level departments. Now, the depth first index, which is created just on the hierarchy ID value itself, is more efficient for returning nodes that are near each other, such as all descendants for a node. We'll also add the root node to the table using the department entire organization. Now, you can set a node to the root node by using the static getRoot method of the hierarchy ID type, or by doing an implicit conversation from the /. Now, before adding new departments, we'll go in and we'll create a new stored procedure that'll help make this just a little bit simpler for us. Now, the procedure add department new takes the ID and the name of the new department as parameters. Now, the third parameter is the ID of the parent department. Creating a new node in this tree is quite a bit more complicated than performing the same operation under the normal org tree. Now, remember, in that environment, all we had to do was create a new department and then assign it a parent ID. However, there is a distinct advantage to using the hierarchy ID, and that is that the operation of creating or inserting a node only needs to be performed once, and then the node and the level is always available. We won't need to constantly traverse the tree to calculate node levels when interacting with the tree, which greatly reduces our overhead, especially in relation to reporting operations when we compare it to something like a standard org tree structure. So we now call add departments new to populate the table. It gives us the identical structure shown in our previous example. Let's take a sneak peek at the actual structure of the hierarchy ID data type for a minute. Now, a hierarchy ID is represented as a path from the root node with /s to delineate levels. For example, in our organization, entire organization is the top level. with operations, development, and parking as some sub-levels underneath that. Now, if field operations was the second child of the operations node, it would hold a node value of 1, then 2. Now, a hierarchy ID may store the node position in a very large hierarchy. Nodes above the hierarchy ID are actually ancestors. So for 1, 2, 2, both the /1/2 and /1 are going to be ancestors of the root item, which is just our /. Now, the ancestor or the / is actually the ancestor for every node, and nodes below a hierarchy ID are simply called descendants. Now, in order to assist in reporting the organizational structure, we're going to go in and we're going to create show department chart stored procedure. Now, this procedure will return all the departments below, including the department passed to the stored procedure. Now, each department is indented based on its level relative to the level of the department supplied as the parameter. If the level were not a table value, the same logic could be implemented using the getLevel method of the HierarchyID data type. So we now call showDepartmentChart to view the operations department and the entire organization. Now, as we discussed previously, this method of reporting a tree structure takes considerably less time and system resources than the comparable method with a standard org tree. Typically, reporting an org chart with a parent-child schema would require a recursive procedure. Here, this can be done with a simple select statement. Let's continue, and here we're going to query each of these org charts a certain number of times and then put some actual performance statistics behind them. Now, notice the dramatic difference in hierarchy ID, which requires no insert, delete, or update statements. Hierarchy ID will also execute no transactions and takes far less execution time overall. Now, this really helps to illustrate the difference between the two types of charts. To summarize the differences, a parent and a child tree is simpler to add records to, but causes a little bit more overhead when reporting the tree structure. By comparison, the hierarchy ID tree uses a bit more overhead to create and insert the nodes, but it improves the system performance. So when you're reporting a tree structure, in the example that we just saw here, which is a common operation and it might be done very frequently on your database server, hierarchy ID seems to be your standout performer. Hierarchy trees constantly need to be revised and updated. For example, one other common procedure we might want to perform on our org is a reparent, which means to move a node so that it has a new parent. In this example, let's move the parking node so that it's now a child of home operations node. For a standard parent-child table, this is quite simple. We simply need to change the parent ID for the parking node. Since all the children of the parking node still really have parking as their parent ID, no further action needs to be taken. Now, the same procedure is actually a little bit more complicated if we go to a hierarchy ID table. Because not only do we have to reparent the parking node, but also everything below it in the organizational tree has to be reparented as well. Now, to make this a little bit simpler, we're going to add a stored procedure called moveParent. Here we go. We're going to use moveDepartmentNew. Let's go ahead and execute the procedure. moveDepartmentNew goes in beneath another parent, and we could also use getAncestor, which we've used here, to determine the current highest valued child for the new parent, and then use getDescendant to create a unique new child node for the new parent. This is the same logic used in the addDepartmentNew stored procedure that I showed you earlier. Next, the stored procedure uses the reparent method to move the department and then all of its descendants beneath the new parent. Now we call moveNewDepartmentNew to move parking, which is currently Department 4 beneath home operations, which is Department 5. And then showDepartmentChartNew is called both before and after the move. So finally, let's look briefly at a couple of additional hierarchy ID methods and then how comparable operations would have to be if we were to perform them on a standard parent-child table. IS descendant returns whether a node is a descendant of another node. Interestingly, a node is a descendant of itself, and here we're querying the operations node to find out which nodes are 2 levels beneath it. Get ancestor will return the ancestor node for a node, and for this you specify the number of levels up the tree as a parameter, and here we want to find out which node is the grandfather or the ancestor that's 2 levels up the tree of the home operations node. When we talk about this concept of hierarchy ID and parent-child, and in this case, grandparent-child relationships, the upfront cost is a little bit more. We spend a little bit more time in setup. The functional cost, the system performance, is increased dramatically when we use a hierarchy ID environment. And we've summarized this a couple of times during this session. Hierarchy ID adds an incredible new value to hierarchical table operations inside SQL Server 2008. Thoroughly enjoyed spending some time with you today. Hope you've learned some neat new things about hierarchy ID. Look for more for us on SQL Server 2008. This is Chris Henley signing off for today.